Hey everybody, and welcome to this video on the point-slope form of a linear equation. So let's get to it. All right, to begin, we're going to find the equations for some graphs that will be lines having a specific slope all going through the origin. So for instance, let's find the equation for a line whose slope is 2 containing the point 0, 0. So what's really nice about this is that if it contains the point 0, 0, that means that's the y-intercept of this graph. So we're looking for the equation of a line whose y-intercept is 0 and whose slope is 2. Well, I think that equation is going to be y equals 0 plus 2x, or just y equals 2x. And here's what the graph will look like. All right, what if we wanted to have a line whose slope was negative 3, but still had the same y-intercept? I think the only difference in the equation would be that we have y equals 0 minus 3x, or just y equals negative 3x. Not so bad, and perhaps we see a trend developing. What if we wanted the slope to be 3/5, still containing the point 0, 0? Well, I think the equation in that case would be y equals 0 plus 3/5 x, or just y equals 3/5 x. And last but not least, what if we wanted the slope to be 7/4, still containing the point 0, 0? 0 is still going to be the y-intercept, the slope is 7/4, so I think our equation would be y equals 0 plus 7/4 x, or of course, just y equals 7/4 x. In each of these equations, we didn't have to have that 0 there. I like to have it, but you didn't need to. And in general, we can say that the equation whose graph will be a line with a slope m containing the point 0, 0 will just be y equals m times x. All right, now what if we want to find the equation for a line with a slope of 2, no longer going through the origin, but going through the point 2 comma negative 5? Well, if we wanted it to go through the origin, that would be really easy. Then we just have the equation y equals 2x. But now we want it to go through the point 2 comma negative 5. And here's how I think we're going to have to do it. We want to take this original graph, the graph of y equals 2x, and all we need to do is move this graph to the right 2 units and down 5 units. But we definitely know how to do that. If we want to move our graph to the right 2 units, all we need to do is replace the x in our equation with an x minus 2. And if we wanted to shift our graph down 5 units, all we need to do is replace the y in our equation with a y plus 5. And so we end up with the equation y plus 5 equals 2 times the quantity x minus 2. And this is the equation for a line whose slope is 2, containing the point 2 comma negative 5. And as it stands, this way of writing a linear equation is called the point-slope form of a linear equation, because the slope of the line is readily apparent, and the point it goes through is also very apparent just from looking at the equation. Now there are a couple different ways to rewrite this same equation, each of which has its own merits. For instance, this one is great because it tells you exactly the slope and what point your graph goes through. Another way to write this is y equals negative 5 plus 2 times the quantity x minus 2. And note all I did was subtracted 5 from both sides of this equation. And this form of the equation in y equals form looks very similar to our slope-intercept form from before. But of course, negative 5 is not our y-intercept in this case. But you can kind of think of this as saying, well, y starts at negative 5 when x is 2, and of course then grows at a rate of 2 every time our x value increases by 1. So very similar to the slope-intercept form of a linear equation, just a little bit different. And of course, the last way to write this equation, and one that's very familiar and comfortable to us, is to actually put it into slope-intercept form. And if you do that, you end up with y equals negative 9 plus 2x, implying that the y-intercept of this graph was negative 9, and of course the slope remains 2. And if we just scroll down a little bit, we can see that indeed the y-intercept is negative 9. So 3 different ways of expressing the exact same equation with the same graph, each of which tells a little bit of a different story. And I'd like us to be comfortable understanding each of these 3 ways of writing a linear equation. All right, let's try another. Now let's find the equation whose graph will be a line with the slope negative 3, but now containing the point negative 4 comma 7. Of course, if all we needed to do is have it go through the point 0, 0, we'd be home free. The equation would be y equals negative 3x. But now we needed to go through the point negative 4 comma 7. And I think the easiest way to make that happen is to take our original graph, which goes through 0, 0, and move it to the left 4 units and up 7 units. Well, we know exactly how to do that. If we want to move our graph to the left 4 units, all we need to do is replace the x in our equation with an x plus 4. And if we want to move our graph up the remaining 7 units to have it go through that point, all we need to do is replace the y in our equation with a y minus 7. And now we've got the equation for the line with a slope of negative 3 containing the point negative 4, comma 7. Of course, there are 2 other ways we could write this equation. We could write it as y equals 7 minus 3 times the quantity of x plus 4. All I did was added 7 to both sides of this equation. This equation right here looks a lot like the slope-intercept form. Of course, 7 is not our y-intercept, but you can think of it as a starting point for y. Of course, this starting point doesn't happen when x is 0. This starting point happens when x is negative 4. And of course, the last way to represent this equation, and the one that's probably the most familiar to us, is the slope-intercept form, which is y equals negative 5 minus 3x, implying that the slope is, of course, negative 3, but the y-intercept for this graph is negative 5. And if we scroll down just a little bit, we see that absolutely our y-intercept for this graph is negative 5. Once again, I'd like for us to be comfortable interpreting all 3 of these different forms of the same linear equation. All right, now let's try to find the equation whose graph will be a line with a slope equal to 3/5, containing the point negative 2, comma negative 6. Now, of course, if all we needed was to have a slope of 3/5 containing the point 0, 0, we'd be home free. The equation would be y equals 3/5 x. But if we wanted to contain the point negative 2, comma negative 6, well, I think what we need to do is take this original graph and move it left 2 units and down 6 units. Again, we know exactly how to do that. I'm going to walk you through it, but maybe you can try anticipating it right now. Well, in order to move our graph left 2 units, all we need to do is replace the x in our equation with an x plus 2. And in order to shift our graph down 6 units, all we need to do is replace the y in our equation with a y plus 6. And now we have the equation for a line with a slope of 3/5 containing the point negative 2, comma negative 6. Once again, this is the point-slope form of the linear equation because the point through which it goes and the slope are readily apparent. Of course, some other ways to write this equation are y equals negative 6 plus 3/5 times the quantity x plus 2. All I did was subtract 6 from both sides of this equation, and while this looks similar to the slope-intercept form, it's kind of saying that y starts at an initial value of negative 6 when x is negative 2, and of course grows at a rate of 3/5 after that. Or of course, you could put this into slope-intercept form by solving for y and end up with y equals negative 24/5 plus 3/5 x, implying that of course our slope is still going to be 3/5 and our y-intercept is negative 24/5, which is really close to negative 5 but not quite negative 5, and if we zoom in on our graph it absolutely confirms that. And note to self, in this case our y-intercept was not an integer. This was a fraction, which means we would have had to eyeball it if we tried to graph this just by putting it into slope-intercept form. So note, in this case, we really had to use this point-slope form of the equation. All right, last example before we try practicing some on our own. Now let's try to find the equation whose graph will be a line with slope equal to 7/4 containing the point 5, comma 3. Of course, if we wanted it to go through the origin, 0, 0, the equation would be easy. We just have y equals 7/4 x. But now we want it to go through the point 5, comma 3. And I think the easiest way to make that happen is to take our original graph and shift it to the right 5 units and up 3 units. And I'm sure you know how to do that, and feel free to anticipate. Well, if we want to shift this graph to the right 5 units, all we need to do is replace the x in our equation with an x minus 5. And if we want to do the remainder and shift this graph up by 3 units, all we need to do is replace the y in our equation with a y minus 3. And now we've got the equation for our graph, which is going to be a line with a slope of 7/4 containing the point 5, comma 3. Of course, I want us to be very familiar with the 2 other ways of representing this equation as well. All right, now it's time to do some practice. And what I'd like you to do is to pause the video and please try to find these 2 equations. One for the line with a slope of 4/9 containing the point negative 7, comma 12, and one for the line with a slope of negative 5/2 containing the point 6, comma negative 10. And when you're finished, please pause the video and we'll reconvene to see how it went. All right, last two practice problems. Now note, it's really important for us if we have a line in mind with a specific slope containing a specific point for us to be able to create its equation. It's also really important for us to look at an equation and know exactly what line it's describing and go ahead and graph that line. So we're going to do one together, and then I'm going to have you practice one on your own. Now let's look at the first equation. Y minus 5 equals negative 2/3 times the quantity x plus 8. Now up until now, our initial gut reaction has been to put this into y equals form, find the y-intercept, and find the slope. So why don't you pause the video and just put this in a slope-intercept form first. And when we do that, unfortunately, we see that we've got a y-intercept of negative 1/3. Now, there's nothing wrong with that being our y-intercept, but if we're trying to graph this by hand, we're going to have to eyeball that negative 1/3, and we don't like doing that. We want our graph to be as accurate as possible. But if we look at our original equation, we notice that this is in point-slope form. It's obvious that the slope is going to be exactly the same. The slope is negative 2/3. But from the x plus 8 and from the y minus 5, that tells us that this graph is going to have to contain the point negative 8 comma 5. And once we know that, we can just graph our point negative 8 comma 5 and then use our slope of negative 2/3 to count out 3 units to the right and 2 units down, and 3 units to the right and 2 units down, of course going in both directions, and we'll be able to piece together our graph in exactly the same way we always have. It's just that the point we're starting at isn't our y-intercept, it's just this random point, negative 8 comma 5. And now that we've graphed our line, we can see that indeed the y-intercept is negative 1/3, but it's great that we were able to graph this without doing any estimation or any eyeballing at all. All right, time for you to try one. Why don't you try graphing y plus 2 equals 5/3 times the quantity of x minus 4. And I'll tell you now, if you try to put this in the slope-intercept form, the y-intercept is going to be a fraction and it's going to require you to eyeball. So why don't you try graphing this using the fact that this equation is already in point-slope form. All right, guys, that's it for this video. I hope you enjoyed, and I hope you found it helpful.